Hello everyone. In this video, I will be discussing about heat transfer by conduction. So before going into a deep conduction, let me clear what is conduction. Okay, so we will discuss four topics, that is Fourier law of heat conduction, one-dimensional steady-state heat conduction through plane wall and through composite wall. Okay, so what is conduction? So conduction is a diffusion of heat due to temperature difference. That is, if there is temperature difference between 2 points, heat will transfer from higher temperature to lower temperature through a solid object. That is known as conduction. Generally, conduction occurs in the solid, and convection, that is also part of conduction, that occurs in a fluid. So how conduction occur? So conduction occur by a temperature difference and due to the molecular interactions. Because as there is a temperature difference, molecules are charged at higher temperature and lower charged at lower temperature. So we can say that conduction is also happening due to molecular interactions. That is by energetic molecules colliding with the neighbor with increasing speed. Examples of conduction are metal strip, etc. Okay, so Fourier law of heat conduction. So what is the statement? Statement is rate of flow of heat through a simple homogeneous solid is directly proportional to area of a section and change of temperature with respect to length. Hence we can say Q is directly proportional to area and temperature gradient, that is dt by dx. So for equalizing the equation, we'll use term K. K is also known as thermal conductivity. So this is the main formula for conduction. So what Fourier has assumed during formulating a formula for conduction, that is, heat transfer is taking place at steady state. Hence, there will be no change in temperature with respect to time. Hence, this equation which we have seen is time independent. Second assumption is no heat generation. Hence, there will be no heat generation from inside the body which is conducting heat. Third, the body is homogeneous and isotropic. That is made up of only a single component, or not a mixture of two or more components having different conductivities. And the main assumption is unidirectional heat flow. It may not be true for all the cases, but for this conduction study we will use unidirectional heat flow. As we have discussed unidirectional heat flow, that means we will only discuss in one direction, and so we will be studying only for steady state heat conduction, that is not changing with time. Okay, so look at the figure. Here plane wall is present. The temperature at the first part of plane wall is Ts1, and at the L length, that is x equal to L, temperature is Ts2. Hot fluid is passing from one side and cold fluid on the other. Temperature at the cold fluid region is T infinite 2, or at the hot is T infinite 1. So according to the Fourier's law of heat conduction, Q equal to Ka dt by dx. Here length is 0 to L and temperature is changing from T1 to T2. So our Q equation becomes T1 minus T2 divided by L by Ka. This L by Ka is also known as heat resistance. So comparing the above equation with V equal to IR, we can say that Q equal to current, temperature difference is analogous to voltage, and L by Ka is analogous to thermal resistance or resistance in electrical circuit. Now for composite wall. If there are more than 2 or 3 walls present in a series, then we can simplify our rate equation as temperature difference between the first and final wall divided by the resistance, sum of resistance of all the walls, that is L1 by Ka1 plus L2 by Ka2 plus L3 by Ka3. So this is the general equation we will be using for composite wall. If it is given that heat transfer is also occurring due to convection, then we will be adding two terms, that is heat convection terms, that is HA, that is the resistance due to heat convection, that is 1 upon HA. Here A will be cross sectional area, and in for conduction area will always be curved surface area. This is the general formula which we will be discussing in another video. Yes, we have discussed this. This is the simplest way to solve the given equation, given figure. So first we will make the resistance type structure in which thermal resistance of all the three walls will be described. Also we will be describing the convective resistances. Okay, so this is the formula for walls in parallel. It is same as the formula for resistance in parallels, like that is 1 by R1 plus 1 by R2 equal to 1 by R. So thermal overall resistance will be R1 into R2 divided by R1 plus R2. Putting this in the formula, we can find out heat transfer through conduction. Thank you for this video, and hope you will give me a good suggestion. I will be making next video on convection. Thank you.